Alright, so let's look at some work on asymptotes, particularly with this question right here. Y equals 2 over x squared plus 1. So the first thing we want to do is find the horizontal asymptote. Now remember, we do that by dividing by the highest power of x. And this particular highest power of x, and in this particular situation, it's going to be x squared. Now the reason we do that is because 1 over x approaches 0 as x approaches infinity. And so we want to look what happens as the x values get really, really large. And so we can find, by looking at this idea here, we can end up seeing what each individual term is doing as x approaches infinity. So we're going to have y equals, so we're going to divide everything by x squared over x squared plus 1 over x squared. Now we know that anything that has a denominator of x is going to go to 0 as x approaches infinity. So this is going to go to 0. This is also going to go to 0. Now this, x squared over x squared, that's going to cancel and go to 1. So really we've got y equals 0 over 1 plus 0, which is 0 over 1, which is 0. That's going to be my horizontal asymptote for this particular question. Now we're going to look at my vertical asymptote. Now my vertical asymptote is when the denominator is equal to 0. So we're going to set x squared plus 1 is equal to 0. Take away 1 from both sides. X squared is equal to minus 1. We have an issue, because to get rid of this squared, we need to do the opposite, square root. We cannot square root a negative number. No, cannot do that. Therefore, there is no vertical asymptote. Does not exist. Next step, we want to find the tangent to the curve. Now, when we're finding the tangent, we need to differentiate and go from there. So let's differentiate what we have here. Y equals 2 over x squared plus 1. Now we have a couple of different options we can use. We can differentiate this, and we're using the chain rule, or we could use the quotient rule. I'm just going to use the chain rule because it's going to be a little bit easier and I didn't leave a lot of space, lol. So we're going to move the negative 1 out the front, multiply by the derivative of the bracket, keep the bracket the same, subtract 1 from the power. So we're left with 2 times negative 1, negative 2 times 2x. So we have negative 4x over x squared plus 1 squared, going from here to there using our negative index laws. Now, we want to show, so the second part of this question is asking you to show that the tangent to this curve is horizontal at the y-intercept. Now we find the y-intercept here. No, we don't want that. From the y-intercept when x is equal to 0. Alright, so let's put that in here. When x is equal to 0, we've got negative 4 equals x squared, equals 0 squared plus 1 squared. And that's typing that in the calculator is going to give us 0. Which means my tangent is horizontal, because when the first derivative is equal to 0, the tangent is horizontal. So we've got our y-intercept. Fantastic. And we can begin to go from there. Now, that is pretty much it. Asymptotes. The next only thing you've got left to do is you've got to sketch what this looks like. Now, the best way to sketch what this is going to look like is going to be looking at what happens around my different values of x. So we found my horizontal asymptote. We've got it as 0. Let's look around 0. We have no vertical asymptote. Let's create a table of values. Let's create a table of signs. It is often going to be really valuable if we don't know how to sketch. Let's look at a table of values and go from there. Because the table of values, when we substitute each one of these in, is going to give us something that looks a little bit like this, where that is my y-intercept, which is 2, sorry. Whenever you're unsure about sketching, table of values is your best friend. That is 100% the way to go. And that is